Hello everyone. Welcome to the mini lecture on electromechanical control technology. Today, we will learn about parameters and wiring of servo motor. Our lesson will cover the following two main topics. Through this lesson, I hope everyone can accurately identify and explain the main parameters of servo motors, including torque, speed, precision, response time, control method, encoder resolution, and dynamic performance. You should also be able to select appropriate parameters based on specific application scenarios. You will learn the correct wiring methods for servo motors, including power wiring, signal input wiring, and motor output wiring. You should be able to perform wiring operations according to specific equipment instructions, ensuring correct connections, stable signals, and reliable operation. The parameters of a servo motor are important indicators that determine its performance and applicability. Different application scenarios and requirements will impose different demands on the parameters. When selecting a servo motor, it is essential to evaluate each parameter according to specific application requirements to ensure the motor can meet operational needs. Additionally, correct wiring methods can prevent motor damage or safety incidents caused by wiring errors. Servo motors are capable of precisely controlling motion and position, widely used in fields such as industrial automation, robotics, and CNC machine tools. The parameters of servo motors include torque, speed, precision, response time, and more. Next, let's learn about the first part, the main parameters of servo motors. 1. Torque. The torque of a servo motor refers to the magnitude of the torque output by the motor, generally expressed in Newton meters, in M. Torque typically decreases as the motor speed increases, due to the internal magnetic flux distribution within the motor. Torque is a critical parameter for servo motors, determining the motor's load capacity and power performance. 2. Speed. The speed of a servo motor refers to the time required for the motor shaft to complete one rotation, measured in revolutions per minute, RPM. Speed is related to the motor's input voltage, number of poles, and design. Speed has a direct impact on the motion speed and position control accuracy of the servo motor. 3. Precision. The precision of a servo motor refers to the motor's ability to control position under specific conditions. Precision is usually represented by position deviation, measured in radians, degrees, microns, etc. Precision is influenced by factors such as the sampling frequency of the servo system, encoder resolution, and control algorithms. Higher precision can enhance the servo motor's performance in position control. 4. Response time. The response time of a servo motor refers to the speed at which the motor responds to input commands. Response time is mainly affected by the motor's inertial mechanical drive system and control algorithms. Shorter response times can improve the dynamic performance and efficiency of the servo motor. 5. Control method. The control methods for servo motors include position control, speed control, and force control. Position control achieves precise motion by controlling the motor's position. Speed control achieves specific speed motion by controlling the motor's rotational speed. Force control applies specific force by controlling the motor's output torque. Different control methods are suitable for different application scenarios. 6. Encoder resolution. An encoder is used to measure the motor's rotational angle and speed, with encoder resolution referring to the angle corresponding to each pulse from the encoder. Higher encoder resolution can improve the servo motor's accuracy in position control. 7. Dynamic performance. The dynamic performance of a servo motor includes acceleration, deceleration, and overshoot. Acceleration refers to the rate of change of the motor's speed. Deceleration refers to the rate of speed change when the motor transitions from high speed to low speed. Overshoot refers to the displacement that exceeds the target position when the motor suddenly stops from motion. Better dynamic performance can enhance the servo motor's capabilities in rapid movement and high-precision position control. In addition to the parameters mentioned above, servo motors also have some other auxiliary parameters, such as motor temperature rise, noise, and power consumption. These parameters are generally selected based on specific application requirements to achieve optimal performance and reliability. Next, let's study the second part, the wiring principles of servo motor. The wiring of a servo motor is generally related to the driver. Typically, the servo motor driver provides interfaces for connecting power, signal inputs, and motor outputs, and it is essential to follow the driver's manual for correct connections. Here are the general wiring methods for servo motors. 1. Power wiring. The power wiring of a servo motor usually has two terminals, typically for AC input and DC output. The connections should be made according to the driver's input power requirements. 2. Signal input wiring. The signal input wiring of a servo motor generally includes position feedback signals and control signals. Position feedback signals are usually encoder signals, while control signals typically include enable signals, direction signals, and pulse signals. These signals need to be connected correctly according to the driver's manual. 3. Motor output wiring. The motor output wiring of a servo motor generally consists of 3 coils, which should be connected properly following the driver's manual. 2 coils are connected to the power supply, while the other coil connects to the ground. It's important to choose the appropriate connection method based on the driver's specifications and model when connecting the motor output. Additionally, the wiring methods for servo motors can vary by brand and model, so it's crucial to follow the specific equipment instructions to ensure correct connections, stable signals, and reliable operation. In this lesson, we learned about the parameters and wiring of servo motors. Servo motors are actuators in industrial automation production lines. They receive pulse commands from controllers like PLCs to achieve changes in speed, torque, and direction, facilitating precise industrial production. Many AGV transport vehicles and robotic arms use several servo motors at their joints, which have a broad development prospect. Lastly, please think about this lesson and complete the following exercises to consolidate today's knowledge points and deepen your understanding. That concludes our lesson for today. See you in the next lesson.